Welcome back to the second video of week 10. Now we're going to look at other debugging tools. Particularly we're going to look at debug and debug once functions, which gives us a more convenient way of calling the browser function. We'll also move beyond browser to the trace and untrace functions, and also look at traceback. We look at how we set breakpoints up in our code, and we'll also look very briefly at some more advanced tools. We introduced a browser in the last video. The browser function is definitely much more helpful and efficient than putting print commands all over your code, but it still involves fiddling around inside your functions, by which I mean that you have to change your function code in order to use browser. We saw that you had to add the browser open brackets, close bracket line of code into your function. So we have to rerun the function with the browser command in it. And then once you're happy that you've sorted all your problems, you then have to rerun the function again with the browser command removed. A slightly more elegant way of using browser is to use the debug function. So debug takes an argument of a particular function, so we can use our like_fun function. And if we put debug of like_fun, that will call the browser every time we run the like_fun function. And then once we've sorted out whatever problems we have with the function, we can stop it running the browser command by using the undebug of like_fun. So we don't actually have to change the function itself. So it's a little bit of a neater way of doing the same thing. I'm not sure it's any more useful than just using debug and undebug, but if you think that the bug that you have is only small and that you'll fix it immediately the first time you try, you can use debug once like_fun, which will only call the browser the first time you run the like_fun function. I don't know whether there's much advantage to this, but I'm just letting you know that it's there. Personally, debug and undebug does the job for me. We've talked before about setting the seed, especially when we're doing simulations or when we're doing code that we want to be repeatable. So it can happen that you'll find that your code only crashes on particular runnings of the function. So you might be in a loop, say, and within the loop you're simulating a sample, and a problem only occurs on a particular iteration of that loop because you've set the seed. So you might know, for example, that the program crashes on the 20th iteration. So if that's the case, and of course this is very situation specific, it'll only arise in certain circumstances, but you can change your function to just call browser on a particular iteration. So for example, you can just use an if statement to call browser on the 20th iteration here. Of course, if you do that, you will still have to remove that command once you've sorted out what the issue is with that particular call of the function. So you'd have to, change your code to remove the browser function. In all these cases, you should remember to hit capital Q when you finish debugging in browser to allow the code to complete out and get back to the OR prompt. Another flexible way of debugging within OR is using the trace function. The trace is a very useful function, and what it does is it gives you the opportunity to call a function when you enter another function. I will give you an example of this in a minute, but it's not a function that I personally make a lot of use of. But you'll see in a second how flexible it can be. It operates as a sort of umbrella function from which you can call debug, debug once, or other OR functions such as ls, for example. The trace function takes two arguments, f and t, where t is the function you want to call, let's say browser, but it could be debug or ls or any other useful function. And f is the function that you want it to be called from. So here, for example, we have trace, licfun, and then browser. So that will work the same way as we've seen previously. As we've said, this is exactly the same as calling debug of licfun. And now if we run licfun passing in parameters here, it will call browser, and it will do that every time until we use the untrace function when we're happy that we've sorted all our problems. As we've said, this is essentially what debug is doing, but with far more flexibility. For example, it might be useful to call the ls function within our function to see the values of everything, all the variables and parameters that are being used by the function, and that would help us see if any of them are named incorrectly or being passed in incorrectly. So we saw on the previous screen that when we were finished with the debug function, we ran undebug, and here it's the same. We run untrace when we're finished with the trace function. If you've run a piece of code and it's already crashed, there's another really useful function called traceback. So we mentioned in the first video that one way of writing code that's easy to debug is to use a small main loop, or a small main function, which calls a number of subsidiary functions from the main function. And what traceback does is it will tell you which function crashed and which functions were called before it crashed. On this slide here, we're also making use of the options function, which sets a lot of the overall options within your OR session. It might be a good idea to go and look at the help files for options, but we're particularly looking at the error argument within options. And the error argument sets the behaviour of your OR session in terms of how it copes and handles errors such as those generated by stop or other errors generated by your OR code. So make sure to have a look at the relevant help file. Anyway, back to traceback. So if you call traceback, as we've said, it'll tell you which functions crashed and which were the functions that were called before the crash. But you can get even more information if you've set the error argument in your options to be equal to dump frames. So what dump frames does is that it will give you a snapshot of the values of the parameters for each of those functions. So you might be able to see from that, or to trace back from that, where your code went wrong. Also, once you've done that, you can use the debugger function to check the individual environments of these different previous functions. Another thing you could do is to set the error argument in options to be equal to recover. So what recover does is it automatically enters debugger when an error is encountered. Now, this is probably overkill really, because all you need to do if you want debugger is just to type the debugger function in. So and you may or may not want to do that in certain circumstances. So like debug once, I'm not sure that this is adding a whole lot to your dictionary of useful functions. When you've finished with traceback, you need to switch off all these extra options and traceback itself and carry on with your normal executable OR. And to do that, you just set error equals null within the options function. So the functions that we've talked about so far, I feel like we started off with a sort of a simple solution and at a whole function level, and we've moved to finer and finer detail, and we're going to continue that trend on this slide. So here, instead of calling a function that will interrogate a whole function, we're going to set breakpoints. So that means that we're going to stop our code on a particular line if we know that around that line is going to be where our problem occurs. So just as the debug function is a slightly finer way of using browser, breakpoint goes finer again. So instead of having to call browser for a whole function, you're just going to investigate the situation at a particular line of your code. So the function we're going to use is called setBreakpoint, and the setBreakpoint function takes two arguments: the file name, which is the name of your source file that you're using to store your code in. So a lot of times you might be using one whole file, one whole OR script as such, for holding all your individual, all your code that you're running for a particular project. But in other situations, you might be holding functions that you reuse, say, in several different places in separate scripts. And it doesn't really matter, just so long as you know where your function is that you want to set the breakpoint in. So the file name, as I say, is the name of your OR script, and then the line number is the line number of your OR script before which you want your code to stop. So the breakpoint will occur before that line is run. Just to give you a simple example of where you might use it, you could say, for example, that you had a call to browser already, and you were currently at a particular line of your file, and your file in this case we'll say is just called work.or. So that's your script. And say you were happy with all the lines up until line 28 of your file. So what you could do, for instance, is you could type n every time from line 13, 14, 15 and so on down until line 28, because if you remember, within browser, n moves you on to the next line. But another thing you can do is to instead of exiting the function and just inserting browser there again and then rerunning the function again, you can just set a breakpoint in your work.or file at line 28, and then instead of using the n, use the c. Remember that what c does is that it will just continue on your code until the next time you hit browser, or you go back to the function or to the or prompt. But if you set the breakpoint and then hit C, it will stop again just before line 28. So that's an example of when you might use it. So we're just going to clean up the last few things about debugging in OR and talk about OR Studio, and then move on to an extended example. In the latest version of OR Studio, there are some new debugging tools that will link OR Studio and the debugging functions better. So there is an overview on the website that is written here, and the URL is there. Also, take a look at the debug menu within OR Studio, and that will allow you to step through code and add breakpoints easily. So instead of using functions like we've described so far, there are menu options which will allow you to debug and add breakpoints. Also, and it's not something we're going to go into, it would only be if you were really interested in debugging code in a more sophisticated way than we've described. There's a package called Debug, which has a very range of debugging tools that you may find useful. But overall, probably what we've described today should do the majority of cases. Just to finish up with debugging, and I've mentioned this already, one of the useful things to think about is using the set.seed function to ensure that every time you run a particular function that you're going to get the same results. This is specifically to do with functions that are simulating or generating random samples from distributions. If you set the seed to being a particular value, for example 1, 2, 3, or 1 is often used in research papers, the number 1, then the random simulations will repeat every time you run the code. So what will happen is that the numbers are what are described as pseudo-random. Another thing which I think I've also already mentioned is not to forget the obvious. More often than not, you'll have problems with your code purely because your brackets are not matching up or for some other very simple reason. Finally, as you know, or you probably know, OR produces error messages but also produces warning messages. So this might be because vector lengths don't match, for example, or for some other reasons. One final piece of advice is not to ignore warnings. They're probably there for a reason. It might be something that doesn't produce an actual error, but it may be a sign that something isn't as you thought it would be, or didn't do the exact thing that you thought it was going to do. So have a look at any warnings and see why they're being produced. There is a warnings function that will display any warnings that have been produced in your code. So for example, if you have a for loop that produces a warning on each iteration of 100, we'll say, all those warnings won't display to the console, but you can use the warnings function, so just warnings, open bracket, close bracket, to display any warnings that OR has given you. So we're going to finish up this week's lecture as usual with an extended example, and there's a screencast for this. The example is going to be to try and debug a version of the find runs function that we saw earlier in the module. I do recommend you work through this code using the lecture note code that you'll find on Blackboard, and the screencast will help you with that. So all the way back in week 2, we wrote a function to find runs of ones in a vector containing ones and zeros. So our function find runs here takes 2 arguments, x, which is a vector of ones and zeros, and k, which is the length of the run that we're looking for. So for example, if we're looking for runs of length 3, k would be 3 here, and then it would find the instances of runs of length 3 within the vector x. This version of find runs here is not the version that we had in lecture 2. It's one that's, if you like, slightly broken so that we can try and find where an error might be. So let's imagine that we had this function, this function here, written in a source file called findruns.or. And the source function here will just run that code. So that will mean that the find runs function is written in memory and is available for OR to use. And then let's say we had a vector y, 1, 0, 0, 1, 1, 1, 0, and then 1, 1. And we want to run find runs y 2. So that will find instances of 2 ones in our vector y. So if we look at y here, we can see that there's a run of ones at the 4th position. There's another run of ones of length 2 in the 5th position, and there isn't another one then until the 8th position. So there's a run of length 2 of ones in position 4, 5 and 8. So if we were to run the find runs function on y with a 2 as the second argument, we'd expect to get the vector 4, 5 and 8. And as you can see here, we don't. So this is wrong. This version of find runs is incorrect, which we knew already, but I mean, clearly it is incorrect. So we want to find where the mistake actually is. So just to remind ourselves what find runs is meant to do, when you go in there, what it'll do is it'll set the length of our input vector, which within find runs is called x. And we'll set the length of x as n. So n should be 9 in the case of y here. And then we're going to create an empty vector called runs. And then we're going to have a for loop. So the for loop is going to run from position 1 to position n minus k. And within the for loop, it's going to see where it finds runs of length 2. Or more generally, it's 2 if k is equal to 2, but for whatever value of k, it'll be finding runs of length k. And if it finds a run of length k, it will add on the position where it finds it onto our runs vector. So our runs vector may become longer and longer. And then at the end it returns the runs vector as being the output from the function. But as we've seen, the function isn't working, so we're going to move on to use some of the tools that we've introduced in the last two videos. Let's try the debug function first. So we can set our debug function to work on find runs. So every time find runs is called, it will open the browser, and we'll be within the browser and able to use interrogate within the function. So here then we run find runs on the y vector, and we're looking for runs of length 2. So because we've called the find runs function, that means that we'll go straight into browser. Okay, so remember that browser stops before it runs each line of code. So at the very beginning, it's stopping before the first line, which is n is equal to length x. So when we're there, we can actually see that we can find out what y is by just by asking or to display y from the console. And if we look at y, it does seem fine. So up to now, we seem to be okay. It's read in y correctly. So let's step through a few more lines of the code by using the n. So using n here, that'll move it from line to line. So remember that we also have a variable within our function called n. So we can't just, if we use n in order wanting to see what the variable n contains, that won't work. It'll just move on to a new line. So we have to use print n in order to interrogate what's in the variable n. So if we do that, we can see that it's set it to 9. So that seems also correct. So far we're okay. Another thing I should have mentioned above is that although our vector is called y outside the function, it's actually called x inside the function. So it would be a good idea to find out what the value of x is here as well. So if you typed x up here after you've checked for y, it should also give you the same values as y did. So x should also be equal to 100111011. That's just something I should have said earlier. So if we keep typing n at the command line, it will continue to work down through the function, and when it gets to the for loop, if we continue to type n, it will go into the for loop. So if we continue, so here it's showing you that it's going, it's got as far as the for loop, and then here it's gone into the for loop, and you can see that it's incrementing I, or it's working on I, and then down here it's just about to do the if statement. So before we go into the if statement, let's just check what I is. So we just type I at the console and it tells us that it's 1. Okay, so now let's break down the if statement here to make sure that it's doing what we want it to do. So the first thing we're going to look at is this I is equal to I plus k minus 1 here. So for I plus k minus 1, well, we want that to be equal to 1 plus 2 minus 1 is 2, because we want to check positions from positions 1 to 2 of our vector x to see are they all 1s. In this particular case, or the particular vector that we passed in, x 1 to 2 should be 1, 0. So here, if we browse x from I to I plus k minus 1, we'd expect that to be equal to 1, 0. But look, it's not that, so that's wrong. So I think the problem here is with the sequence that's set up here. So if we type I to I plus k minus 1, that should be equal to 1 to 2. So if we type that in, we should get 1 to 2 here, but we just get 2. And the reason for that is that this colon here is taking precedence over the plus and the minus. So it's actually just going I to I, which is 1 to 1, which is 1, and then it's adding plus 2 minus 1 to that and getting 2. So it's not doing the sequence as we thought it would. So the reason for that is because we should have brackets here around the I plus k minus 1 in order to make sure that all of that is on the right hand side of our sequence. So it's going from I all the way to I plus k minus 1 instead of just from I to I and then adding k minus 1 to it. So in fact we should have written in our code originally, it should have been I to open bracket I plus k minus 1. So that's where our problem lies. So we make that change and we save it in findruns2.or. And then if we run that on our Y2, we should get 458. So here you can see that actually that didn't happen. So we still have another problem. It wasn't just the problem with the brackets. So we're going to have to continue on to see what other problem there is. So bear in mind that this is also in the screencast, so you'll get more detail about what we're doing in that. But in order to keep practicing using our new debugging functions, we're going to use a different function now called set breakpoint. So we're going to use the set breakpoint function on our new version of the code, which is in findruns2.or. And what we want to do is set a breakpoint at line 5. So our second argument here is going to be 5. So when we try our findruns Y2 again, it'll go all the way through to line 5 and then stop. Recall that line 5 is the line that the if statement is on. So the breakpoint is going to stop the code just before the if statement. So again here we can check and make sure that that the sequencing here is correct. So it should be checking each 2 values of the vector x. So the first time when we go in, it gives us 1, 0, which is correct. So it appears that that this piece of code here within the if statement is now right where before it was wrong. Okay, so we can type a C and that will continue on the code until the next time it hits the breakpoint. So it'll go all the way through the code and back around to line 5 again and then stop again. And if we check at this point, we can see that it should be looking at from positions 2 to position 3 of the vector x, and that gives us 0, 0. So it does appear to be reading in the right pairs of data. So obviously this is a faked up example where we've deliberately set errors to be in the code. But let's take advantage of that and let's call the browser function at I equals to 8. So so we'll have a look at that on the next slide. So within the findruns3 or script, you'll find that browser has been written at I equals 8. So if you have a look at the code, and again there's more explanation as to why we've done this in the screencast, you can see that there's an if statement in there that only calls browser when I is equal to 8. So let's call our find runs function with the vector y and length of ones of vector ones of 2 again, and it goes all the way through and comes out again at the end with the result 4, 5. So it never got to a point where I was equal to 8 because it didn't go into browser at all. But we know that it was meant to go up as far as I is equal to 8 because we wanted to check all the pairs of the adjoining pairs of the y values. So why isn't it doing that? Well, the upper limit of the loop, if we look at the code in find runs 3, is n minus k. But n minus k, in fact, is 9 minus 2, which is 7. And it should be going all the way up to 8 to check the 8th and 9th values to see whether they're a pair of ones. So we need to change the loop from I in 1 to n minus k to I in 1 to n minus k plus 1. So if we make that change, and actually you'll find it in findruns4.org, and run that piece of code again, or run that piece of code for the first time, in fact, and then call our find runs y, 2, we'll get the result 458. So it finally works correctly. So that's the end of the material for this week. Just to summarise, we can say that you can solve many problems in OR code when you're using OR 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 Studio by structuring your code well in the first place. So what this means, as we've said, is to write small functions, possibly reusable functions, to avoid you having to reinvent the wheel over and over again. Another advantage to writing small functions is that when you do have to debug, you can interrogate individual functions, and it's easier often to find where the error lies. Another thing to do is always to include lots and lots of comment statements. We've discussed the advantage of using browser and debug functions instead of using print statements within your code. It does make debugging far easier. And finally, to check out the debug menu within OR Studio to see how you can add breakpoints and step through code outside of changing the OR code itself.